Problem 48, Quantum Mechanics. The question is, the energy eigenvalues of a particle in the potential V of x equal to half m omega square x square minus ax r. Here we have to find out the energy eigenvalues. The potential V of x is given. Now, by observing the potential, we can see that there is a correction term minus ax. Hence, we can solve this problem using perturbation theory. Using perturbation theory, we can find out what is the first order correction in energy and what is the second order correction in energy. And from that, we can calculate the total energy En. First, let us write the given potential V of x equal to half m omega square x square minus ax. Now, what is the Hamiltonian? Hamiltonian is kinetic energy plus potential energy. This is equal to px square by 2m plus half m omega square x square minus ax. We can write it as this h equal to h0 plus h dash, where h0 is equal to px square by 2m plus half m omega square x square, which is the unperturbed Hamiltonian, and also we have the perturbation h dash, that is equal to minus ax. So in this problem, the perturbation h dash is equal to minus ax, and using this h dash is equal to minus ax, we can calculate what is the first order correction in energy and what is the second order correction in energy, so that we can have the total energy En, that is equal to the En0 plus En1 plus En2. First, let us find out what is the first order correction in energy En1. En1 is given by n h dash n, where h dash is the perturbation minus ax. En1, this is the first order correction in energy, that is n. What is h dash? H dash is minus ax, so n minus ax n. Now let us take minus a outside, then n x n. We know that for a harmonic oscillator, the expectation value of x, that is n x n, that is equal to 0. Therefore, the first order correction in energy in the given problem is 0. If the perturbation h dash is equal to minus ax, then the first order correction in energy is 0. Now let us find out what is the second order correction in energy. It is represented as En2. We can find out En2 using the formula. En2 is equal to sum over m not equal to n, then modulus m h dash n whole square divided by En0 minus em0. Now let us substitute the value of h dash in this equation, so that we will get the second order correction in energy, that is equal to sum over m not equal to n, then m h dash, substitute minus ax, then n, then square divided by En0 minus em0. Now we can write it as sum over m not equal to n, then modulus, then m minus a. Now what is x? In harmonic oscillator, x is given by h bar by 2m omega whole raised to half a plus a dagger. Now substitute the value of x here, that is h bar by 2m omega whole raised to half, then a plus a dagger, then n square divided by en0 minus em0. Now let us take the constant term outside the summation. Then en2 is a square h bar by 2m omega, then sum over m not equal to n. The term inside the summation is modulus m a plus a dagger n whole square divided by en0 minus em0. Now this is equal to, now let us separate the term. Then en2 is a square h cross by 2m omega. Then inside the summation, let us separate the terms. That is sum over m a n plus m a dagger n square divided by en0 minus em0. We have just expanded the terms inside the summation. Now this is equal to a square h bar by 2m omega, then sum over m not equal to n, sum over m not equal to n, then modulus. Now let us see what happens when a operates on n. When a acts on n, you will get root 10 n minus 1. Therefore, the first term is root 10, then m n minus 1 plus, when a dagger operates on n, you will get root of n plus 1 and the state n plus 1. Therefore, the second term is root of n plus 1, then m n plus 1 square divided by en0 minus em0, divided by en0 minus em0. Now after simplification, you will get a square h bar divided by 2m omega, then sum over actually this summation is not required after simplification. After simplification there will be no m, only n will be there. Therefore no need for summation. Therefore the answer is a square h bar by 2m omega, then n divided by en0 minus en minus 1 0 plus n plus 1 divided by en0 minus en plus 1 0. This is the final answer and after simplification. This is a square h bar by 2m omega, then n divided by h cross omega plus n plus 1 divided by minus h cross omega, and that is nothing but minus a square divided by 2m omega square. That is the second order correction in energy is minus a square divided by 2m omega square. Now we have the first order correction in energy, the second order correction in energy, and also the energy corresponding to the unperturbed Hamiltonian, which is En0, that is n plus half h cross omega. Therefore, the total energy En is En0 plus En1 plus En2. We can represent it as En, that is equal to n plus half h cross omega plus 0 minus a square by 2m omega square, that is equal to n plus half h cross omega minus a square divided by 2m omega square. Therefore, from the given option, option A is the right option.